Another physical property that we can take, but this time on a liquid, is its boiling point. Now, the boiling point is, unlike the melting point, a very easy proposition. All you need is the equipment that you have right in the drawer. Here I have a large test tube, and I have that same thermometer we use for taking a melting point. It's got the right range. I have to remember that. And the material I'm going to take a boiling point of is this liquid. It's called secondary butyl alcohol, or 2-butanol. And I see from the bottle here that it has a boiling point of 99.5. So that's going to be within the range of our thermometer, so we'll be able to measure its boiling point. Now, here's the setup. You're going to see in your hood a lot of clamps and rings and such, and the clamps that you're going to use for this particular determination are called 3-prong clamps. And they're 3-prong clamps because they've got 3 prongs on them. You're going to use the 3-prong clamp, which has a rubberized clamp portion, okay, for holding the thermometer. And you are going to use a 3-prong clamp which does not have rubberized clamps, this one for instance, to hold the test tube, which is going to hold your sample. Now, some people like to use these. Now, these are fine. These are called utility clamps, but if they are rubberized and you want to hold the test tube, I suggest you think twice about doing that, because these rubber sleeves have a tendency to melt directly onto the glass. And when you melt them onto the glass, they are melted onto the glass, and you can't get them off. Okay? So try to avoid using these utility clamps, which have the rubberized sleeves over the clamp portion. Okay, we'll just get rid of that. And now each hood is provided with all kinds of utilities. Like, for instance, we've got vacuum. That's actually going to be very helpful, as you'll see. We have air, and then we have gas, which you're familiar with from general chemistry, and cold water, which operates the gooseneck faucets at the back of the hood. So I've got my small burner here. We call this a micro burner, attached to the gas, and we're going to start it. It doesn't have to be that there. Okay, so I got it. Now that is considered a cool flame, okay, because it's kind of an orangey flame. We can make it hotter by simply cutting the amount of gas per air that's let in there, and we increase the amount of air by just turning it in a certain direction. So this is a hot flame. Okay, we're not going to need a very hot flame for this, so let's put that in the back. We got that started. And here's a sample that I'm going to put into my test tube. We'll put in maybe, let's say, 2 milliliters. That's more than enough material. Okay. Okay, now we got to do 2 more things. I'm going to put a couple of boiling stones in there. These are called boiling stones because they facilitate the formation of bubbles when you want to boil something. And all they are really are silicon carbide chips. Silicon carbide has the same crystal structure as diamonds, so they're actually pretty resilient. I'll put 2 in there. And then we're going to put a little bit of glass wool around the top of the thermometer, like this. Okay. Now, what is this glass wool for? Well, the glass wool is used to prevent fires from occurring in boiling point. Now, how does this happen? Well, sometimes a student will heat up this liquid to such a temperature that the vapors will climb up, and being more dense than air, will simply fall down, and if the flame is under here, they will start on fire. And then you'll have a nice fire going here. That's never bothered me too much because most organic molecules burn with a very sooty type of flame. If you're dealing with diethyl ether, obviously, you've got to really watch yourself because that when it burns, it actually detonates. So here we have here's our flame, and you'll notice that I have put the reservoir of the thermometer about an inch above the level of the liquid. If you put it too far away, you're going to have to heat this too hot in order to get a temperature registered for the boiling point of your liquid. If you put this down too close to the liquid, the churning due to boiling is simply going to cover up the thermometer well there, and what you're going to have then is a boiling point that's too high. So what you do is you hold the burner in such a way that we call it wafting across the bottom of the tube. It doesn't have to boil too vigorously. Now, at this point, you'll see that we're getting a lot of boiling. In fact, the temperature is rising. It's up above 70. It's going up to 80 right now. Some students think that, that's the boiling point. No, it's not. The boiling point is going to be when you actually reach a temperature at which the boiling then gives you a constant value. So let's just heat this up again. Okay. Unlike the melting point, you can take the boiling point over and over and over again for the liquid in this tube as long as it doesn't decompose when you're heating it. There are some liquids that actually do decompose. But melting points you cannot take over again once you have taken them once. Now, okay, this is up to about 90, 92. It hasn't stopped rising. It's up to 93, 94, 95. And while you can't see it from where you are, from your vantage point, there is what we call the vapor ring here, which is where the liquid has been vaporized and is now condensing. And it's getting up near that plug of glass wool. And so we've got to be careful about that, okay? That it doesn't flow over and start a fire. Okay, so we get steady bubbling down here in the test tube, and then condensation in a regular fashion down back into the sample, and that should constitute the boiling point. And it shows here to be at about 98 degrees. Now, this is stated to be 99.5, so we're actually pretty close. And boiling point, by the way, is, unlike melting point, is sensitive to the atmospheric pressure. Okay? So when you take a boiling point in Chicago, it's going to be a couple degrees lower than if you take the boiling point in New York City. Okay? Because we're about 700-800 feet above sea level here, whereas New York City is at sea level. So it's going to have a higher pressure there. And we can see that this has leveled off at about 100. And so we're going to call that our boiling point. And that's all there is to it. So we just simply shut things off. We wait till this apparatus cools. Don't handle it right now. It's very hot. It's 100 degrees. And then we clean up, and we've taken a boiling point. And that's it.